goes behind a trampoline is kinetic energy, which is the energy of motion. You'll see in a clip in a second as Rain jumps, her greatest kinetic energy is going to be right before she leaves, or right as she leaves the trampoline, and right as she lands on the trampoline. And she's going to have no kinetic energy at the height of her jump. And the reason for that is because with potential energy, the higher you go, the more potential energy you have. And when you're reaching your height, you're losing your speed, so you don't have as much kinetic energy.
The second concept that goes into making a trampoline work would be potential energy. Potential energy is the energy able to do work. It's the energy that is stored in an object. In a couple seconds, you're going to see another video of me jumping. And as I jump and as I try to gain more height, you're going to see that I slow down and that my kinetic energy turns into potential energy. The higher I jump, the more potential energy I'm going to have. So this is because of the equation PE equals mgh, mass times gravity times height.
Yes. Our third concept, which is Newton's first law, says that an object at rest will stay at rest unless acted on by an outside force. And the clip you'll see in a second, Rain is simply standing on the trampoline because nothing is acting on her. This law is why she isn't shot upwards by just simply standing on the trampoline. As she starts to bounce up and down, her legs are acting as the outside force that is causing her to start moving and not stay at rest. Her legs and gravity are also the outside forces that stop her from moving and going back to rest. Our fourth concept is Newton's second law, which states that F equals ma, force equals mass times acceleration. Therefore, it would require more force to move a heavier object or to bounce a heavier person on a trampoline. To demonstrate this, I had my little brother try to bounce me and had myself try to bounce him. This way you guys could see who exerted the most force on the other, or who moved the other the most. Our fifth and sixth concept is Hooke's law and Newton's third law. Hooke's law states that the force needed to stretch the springs is proportional to the length of the stretch. The heavier the jumper, the more stretched out the springs will become. This goes along with Newton's third law, which states that for every action there is an equal and opposite reaction. Hooke's law also deals with springs in equilibrium. The springs will work to go back to equilibrium once you stretch them. This is why you bounce, because when you stretch all the springs snap back together and then shoots you up. Let's look at a clip of Rain jumping and see how the springs react to the force that she exerts on the trampoline.
For our seventh concept, we have the seat jump. As two people jump on a trampoline together, they're both in contact with each other. Therefore, the transfer of energy occurs, allowing one person to steal energy from another. In order for me and Kirsten to steal one another's energy, one of us should hit the trampoline halfway through the other's bounce. The closer we are to each other, the greater the transfer of energy is going to be. Let's go try it out and see if it works.